All right, you guys, today we're going to talk about how we think about area and perimeter with variables. So I'm asking you to think about two different things that we've talked about so far in our review this year. So we've already talked about area, and area for like a rectangle would be the number of squares inside of it. So if I had a rectangle that was 1, 2, 3, 4, 5, 6, 7 squares long, and a length of 7, so units long, and then it was 1, 2, 3 units wide, then when I draw the whole thing together, it's very easy for me to say, well, area, right? We know that area is the length times the height. Or we also can say the base times the height. Sometimes people say base times height, which is the length of the bottom line times the height. But I'm going to say length times height. Or we could say width times height, how wide it is times the height. It just all depends on how you're looking at it. And in this case, we would say the area is equal to the length, which is 7, times the height, which is 3, and 7 times 3 is 21, so the area is equal to 21. And I can see that here because I can see that here's how I know what the area is when I look on this graph paper. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 square units inside. So that also reminds me that I need to use units here. It's 7 units times 3 units is going to be 21, and they're not units. These are, if one of these lengths is a unit, then the full square, then a square that is that length, like a square like this, a square like this is 1 square unit. So I am going to make sure to note that in here and say this is 21 square units. Or maybe I'll write out the whole word units. All right, so then for the same rectangle, if I was going to talk about perimeter, I want to use the exact same rectangle. The perimeter is, instead of what's on the inside, how many squares it takes to fill the space, we're going to talk about the distance around the outside. So the perimeter for the same 7 by 3 rectangle is going to be, how long is this length here? It's going to be 7, and then if I keep walking around it, that's 3. Because I know these are parallel lines, this line has to be the same length. So even though it doesn't say it right now, and it doesn't say it up here, I know that this length is also 7, and that this length over here is going to be the same length as that, so that's also 3. So I'm just going to add all of those up. So perimeter is always just the total length of sides. So the perimeter equals side 1 plus side 2 plus side 3 plus side 4. And since we're adding them, the Math Antics guy said in the video, it doesn't matter what order you add them in. But I'm just going to go around it because like when I visualize perimeter, I just visualize myself walking around it. So I'm going to visualize the perimeter is the, sloppy writing, is the length around there, and then the length there, and then the length along the bottom, and then the length back up the other side. So that is, when I visualize it, I do 7 plus 3, which I know is 10, plus 7 plus 3 again, which is 10 more. So the perimeter is 7 plus 3 plus 7 plus 3, and I can say that that is the same as 10 plus 10, or I can say that that is the same as 20. Okay, so we know what perimeter is. Perhaps later I will write down their meanings over here again if you're not sure, but you need to be asking me if you don't know. But now I want to talk about, we're going to talk about this with variables though. So what if I have a side where what if I have a triangle like this where I know how long this side is, but I don't know, or sorry, not a triangle, a rectangle, but maybe I don't know how long this one is. Like you can look at that and go, well, it looks like it's about 3/4 of the way, but we can't really be sure. We can't be sure if it's 0.75 or 0.76 or 0.7500000001. We can't really be sure. So because we don't know this length exactly, I'm going to give it a value for the value that I give unknown numbers, which is x. Remember, a variable can represent an unknown number. So, but I definitely do know that this length here is definitely 3. I saw all of those points locked together. And so I know that this length is also 3. And I don't know what this length is, but I know it's the same as this. So this length also has to be x. So the question is, how do I figure out the perimeter and the area for this rectangle? So I'm going to just draw a line here to separate these while you think about that for a minute. How am I going to do that? This is area and perimeter. Let's use the word and. Area and perimeter with variables. Now, the reason that we're going over this is because we're about to start doing this a lot with algebra tiles, and I want it to just make sense. So the thing is that everything still works the same. Nothing is going to change. We talked about up here at the top that area is the length times the height. And in this case, the area is still equal to the length times the height. But in this case, the length is not, like I don't know what the length is. The length looks like it's an x here. The height is still definitely 3. So the area now is going to be equal to, I know that the height is 3. And what do we have for x? Well, because we don't have anything else, we're just going to do x times 3. When you guys watch the video, the Math Antics video about how to write things with variables, we're going to say that the area is equal to, that x times 3 means 3 x's, right? It means x plus x plus x. And so that's 3 x's. And so the way we write that is 3x. That's what that means. This means 3 times x. And those are the same. That's the same. So this is how we can think of this as like 3 different x's. The area is the same as 3 times x. I don't know what x is, but when I find out what it is, I'll be able to calculate the area of this very quickly. But the point is that this is all I need to know. And that I can just, like this year, you're going to have to get comfortable going, well, you know what? I don't need to provide a number answer for this. I need to understand that the area is equal to 3 times that number. And I can't go further than that right now because I don't know the value of x. And that's all right. So we're just going to be cool with that. Up here, you know, with this one, before they start doing variables, people feel like they need to like have a final number answer. But you don't really need that. What you need to know is that what perimeter means is the distance around the shape, and I'm going to add those distances together. And if I don't have one, then I'm going to say all of the distances that I do know as simply as I can, and then the ones that I don't know as simply as I can. So now let's try that with perimeter. So here's the, you know what I'm going to do? I'm going to use my scissor tool. I'm going to try to cut this out. See what it does. I'm going to copy, and then I'm going to paste, and then I'm going to bring that down here. So fancy. Okay. This stuff didn't exist when I was in middle school, you guys. Okay, so same one. This is 3 and x and 3 and x. So for perimeter is the same thing, right? Perimeter is going to work the same way. So perimeter is equal to side 1 plus side 2 plus side 3 plus side 4. And so, you know, it's just all of the sides. If there's 5 sides, then you have more sides. But in this one, we only have 4 sides. So the perimeter is going to be, if I walk around this, you know what, I'm going to use my same, I'm going to change my colors again. It's going to be, you know, here's, let's call this side 1, side 2, side 3, and side 4. So if I think about it like that, I'm going to color code this. This is going to be side 1, I said, was the top one, so that's X, plus side 2 is 3, plus side 3 is X, plus side 4 is 3. Now, this is all the information that I can have. I can't put any more information in for X. I'm going to be okay with that. We're just going to go, all right, cool. I don't know that. I'm just going to patiently wait. Maybe I'll never find out how long that is. But in the meantime, I'm just going to leave that number as X. And what I'm going to do is I'm going to try to simplify this. So I do know this part and this part can be combined together. So this length is 3 and this length is 3. So I at least know that the sides, that these two sides make, like, they have a total of 6. And then the top and the bottom sides have a total, they both are X and X. And I don't know what X and X, I don't know what their total value is. I know what 3 plus 3 is. I know that 3 and 3 is 6. But because I don't really know if X is, if it's 8.5 or 8 3/4 or 8, you know, and 76/100ths, because I don't know that, I can't write in a value for them because I don't know what numbers I'm adding. So what I'm going to do is I'm going to say, well, it's just 2 X's. This is going to be an X and another X, so that's going to become X plus X. So the perimeter now is X plus 6. Now we saw up here that 3 X's, remember we already did this one, 3 X's, X plus X is the same as 3X. So what do you think X plus X is going to be? Hopefully, in your head, you're thinking that X plus X is going to be, because if X plus X plus X, if there's 3 X's, if that equals 3X, then hopefully it makes sense that X plus X equals 2X, and that the full perimeter is going to be 2X plus 6. This is a little bit weird. It's a little weird to have these variables. I recognize that, but it starts to make sense, and they do act the same way. Like if X happened to be 10, then I would say, okay, well, the perimeter is 2 times 10 plus 6. If X happened to be 8.5, I would do 2 times 8.5 plus 6, and that would give me this. But because I don't know what X is, this is as far as I can go. I can't simplify this anymore. I can't tell you any more about the perimeter until I find out what X is. And right now, I don't have enough information to do that. So I'm just going to write this down. All right, I'm going to give you guys some practice to work on this idea right here, but this is the start of the 8th grade year, and this is what I'm going to start talking to you guys about in this lesson. In the first lessons of the year. So what we've learned is that we still think about area and perimeter the same way when there's variables, but we just have to say, we just have to go, you know what, sometimes I'm not going to know what the variable is, and so I'm just going to hold space for it and remember that when I do find out, I want to remember how to use it. And that's all we really have. All right, so if you haven't